This video will show you how to give common names to some branched alkanes. So here's the first alkane we're going to try. And so let's start off with the IUPAC name, and we can compare and contrast that with the common name. Now for IUPAC, we need to look for the longest continuous carbon chain. 1, 2, 3, 4, 5, 6, and we'll want to name that parent chain. So for 6, that's going to be hex, and then ane. So hex for 6 carbons, ane for all single bonds. Now we have just one group coming off of that chain. That's going to be a fluoro group. And we need to figure out what number that's on. Looks like numbers are going to be much lower starting from the left. So that's going to be on the 1, 2 carbon. So that's going to be 2-fluoro. And there's usually no space, hexane. Put a dash between the number and the letter. Now, what about the common name? For the common name, we need to study the carbon chain, study that overall hexane chain, and then study this carbon of interest. This is the carbon that is connected to our functional group, to our fluorine. When we study that carbon of interest, what we notice is that it is connected to 2 other carbons. And since it's connected to these 2 other carbons right here, it's considered secondary. So those 6 carbons are secondary, and that would be sec. And then we put a dash, and we put hexyl, because now the 6 carbons are actually the group. And instead, the fluoride becomes the root of the name. And so we've switched things around. That fluorine that was a functional group becomes the root of the name, and the alkyl group becomes a group, and we give that the overall name sec-hexyl. Let's try another example. Now, this is an important example. I'll show you why in just a second. Let's look first at its IUPAC name. Longest continuous carbon chain, 1, 2, 3 carbons. So that's going to be propane. And then the iodine as a group is called iodo, and it's located on the second of the 3 carbons. So we're going to have 2-iodo-propane. What about a common name for this one? Well, we know we need prop. The question is, what kind of propyl? Is it N-propyl? Is it all right in a row? Well, it doesn't really look like it. You might say, okay, well, just like above, this carbon is connected to 2 other carbons. And that's really tempting to say, well, just like the example above, we have this carbon connected to 2 other carbons. Must be sec-propyl, right? But what you have to recall is that there's just no such thing as sec-propyl. That doesn't exist. This is the only isomer of propyl, and so we're going to call this isopropyl, and the iodine becomes the root of the name iodide. Isopropyl iodide. Now, let's try another example. In this example, we need to first look for the longest continuous carbon chain. We've got 1, 2, 3 carbons in the longest continuous carbon chain. So for IUPAC naming, our parent chain is just going to be propane. Now there are two groups coming off propane. There's a carbon group here and this chloro group down here. And this one carbon group, meth, represents one carbon, YL for the group that's going to be a methyl group, and we're just going to number that with the groups coming off carbon 2, so it'll be a 2-methyl and 2-chloro group. We have to alphabetize these two groups. The chloro comes before the methyl, so 2-chloro dash 2-methyl and propane. Now, what about the common name? Well, I'm going to actually get rid of this branch because in this circle, it might confuse us when we're trying to tackle common naming. For common naming, we need to look at that alkyl group as a whole. And so we need to say to ourselves, well, here is our carbon of interest. What's going on for that carbon of interest? Well, it's actually attached to 1, 2, 3 other carbons. So it's not secondary, but it's tertiary. Tert for attached to 3 other carbons. So this alkyl group is tert, and the total number of carbons are 1, 2, 3, 4. And so our prefix for 4 is butyl. And so this becomes a T-butyl group, a tertiary butyl group. So what we've got for our alkyl group is T-butyl, and then our chlorine becomes chloride. So notice the contrast here. In IUPAC, chloro is the group. In common, chloride is the root. In common naming, all of the carbons come together to make one big 4-carbon alkyl group. In IUPAC naming, here we had a 1-carbon group on a 3-carbon chain, and so that does add up to a total of 4 carbons. Let's try just a few more examples. What about an example like this? So let's just draw it a little bit different. We can draw out the carbons for a change of pace, just to show you a little variety. Let's do IUPAC first. So let's look for the longest continuous carbon chain. So we've got 1, 2, 3, 4 carbons in the longest continuous carbon chain. We've got a group right here off the chain. It's a 1-carbon group, so meth means 1 carbon. And then we've got this bromine, or this bromo group. So then we need to number. We need the groups to have the lowest possible numbers. If we number from the left, the bromo will have a 1 and the methyl will have a 3. So that'll give us 1, 3. Let's switch colors. Try numbering from the right. If we number from the right, the methyl will have a 2 and the bromo a 4. Those are higher numbers, so we prefer the 1, 3. So we want to get rid of that green numbering, so we're not going to use that. I'm going to stick with the 1, 3. So then our methyl group is located at carbon 3. Our bromo group is at carbon 1. We're on a 4-carbon chain. But is our prefix for a 4-carbon chain. So butane, we need to alphabetize and put the bromo before the methyl. And so we end up with 1 bromo, 3 methyl, and then butane. Well, what about our common name? Again, we should get rid of this. It might confuse us when it comes to common naming. For common naming, we need to look at this alkyl as a whole group. Okay, well, how can we do that? Well, let's look at the total number of carbons here. There's actually 5 total carbons there, so we have some sort of pentyl group. What kind of pentyl group? do we have? Is it N, all straight chain? No. Is it secondary? Well, we have to ask ourselves, well, is the carbon of interest attached to how many other carbons? Just one. So it's not secondary, it's not tertiary. The only variation on N then for another isomer is iso. So we have isopentyl as long as that branch is one from the end of the chain. Now sometimes folks ask, well, what if that branch had been coming from here? What if there had been a branch from this carbon? What would I name that? That's not sec, that's not iso. Common naming just doesn't have a name for that particular spot, for having a methyl at that particular spot. But in this case, we do have a common name, and so our common name is isopentyl. Notice how iso doesn't have a dash before the group. We're at isopentyl and bromide. Let's try another example problem for you. So let's look for a longest continuous carbon chain here. What if I go 1, 2, 3, 4, 5, 6, 7, 8? Or I could try another combination just to see. What about 1? Be sure to count the first carbon. 2, 3, 4, 5, 6, 7. So if I go down here, I only end up with 7 carbons. 8's a better carbon chain, longer carbon chain. And so that looks like my longest options. So I'll keep it left to right in orange for those 8 carbons. So that will give me octane. And then I look and see, okay, well, I have a methyl group here. And when I go down to this branch, it looks like an ethyl group with a branch coming off of it. So what am I going to do down here? I don't have a great IUPAC name for this branch. There is a method with IUPAC to have a group within a group or a group on a group, but most people find it easier to go ahead and give this 3-carbon group a name. And if I'm connected to the center of 3 carbons, what I want you to recognize is that we have propyl, and we have the carbon of propyl connected to 1, 2 other carbons, but it's not sec propyl. No, there's no such thing as sec propyl, so this is isopropyl. And it's convenient to use that isopropyl name. And then we need to number this. We can try left to right. 1, 2, 3, 5, 6. If we do that, the 2 groups will have the numbers 5 and 6. Seems a little high, so let's see what we can do. 1, 2, 3, 4, 5, 6. From the right, the groups are 3 and 4, so that will be preferred. 3 and 4 will be lower than 5 and 6. Then we're going to have a 3 for the methyl and a 4 for the isopropyl. And so then if we go through and we do the whole IUPAC name, we'll have, oh, and we have to alphabetize it. Now, some folks want to go, okay, I comes before M. Nope, nope, nope. We have to alphabetize instead by the methyl, the propyl. We ignore isosec and tert when we're alphabetizing, just like we ignore di, tri, and tetra when we're alphabetizing. So we'll actually look at the M and the P and go, okay, we need to put 3-methyl first. So again, when alphabetizing, ignore di, tri, tetra, ignore iso, sec, tert. And then the root is octane. So we're applying this common group to an otherwise IUPAC name, and that does happen a lot. Let me show you one last example like that. And so here's that last example. Let's just give you one more idea that's a lot like this. What if I have a ring cycloalkane that looks like this? Okay, so it's a ring, so it's a cyclo. It's got 5 carbons, a pentagon, so it's cyclopentene. And then I have this group coming off of it. And if I can recognize that, oh my gosh, there's 1, 2, 3, 4 carbons on there, and those 4 carbons are arranged in a specific way so that that carbon of interest is actually connected to 1, 2, 3 other carbons. It's not secondary, it's 3, it's tertiary. So what we have there is T and 4 total carbons, so T-butyl. So we can recognize that that's a tertiary butyl group. This is T-butyl cyclopentene.